Hey there, grade 5 teachers. Let's have a look at some ways that you can connect computer sciences into your energy unit. Grade 5 computer sciences is a lot around design thinking and creating computational and other artifacts. Having students also move into using a block-based program like Scratch to create computer programs is a piece of your computer science as well. So anytime students can create something in a system like Scratch to show you what they know about another topic, you're going to be able to cover computer sciences along with that other topic, and students are going to get a deeper level of understanding of what they're doing with those computer science skills as they're making connections to other knowledge that they're sharing. So your computer sciences curriculum talks also a lot about computational thinking and creativity and design processes. So those are those key pieces of the organizing idea of computer science that we see woven all the way from kindergarten up through grade 6 in the overarching ideas. We want students using computational thinking, design thinking, and creativity from kindergarten through grade 6 as a part of their computer science learning. So anytime that you can make connections to these concepts or bring them into your other topics or your daily lessons and routines, you can help students get a deeper understanding and increase their skills in these areas. And that's just going to really help build a strong foundation for those computational thinking and design skills as they move forward. In grade 4, students are asked already to design an artifact, and in the knowledge it tells us that an artifact can be an algorithm or a model or a prototype or even an experiment or some type of object. So essentially, anything the students are creating could be considered to be an artifact. And we can see in grade 5, students are still being asked to design an artifact, and they're also being asked to engage in the design process to create a computational artifact. And a computational artifact is defined as basically anything that's created on a computer or using technology. So this could be an actual computer program or a block-based coding program, like they could make a game or something in Scratch, and that's going to hit these skills as well as all those ones that we see that are specifically connected to beginning to learn a block-based coding language. So again, something in Scratch demonstrating knowledge on another topic is hitting that topic as well as all of that CS knowledge and skills too. Students creating an audio or a video presentation qualifies as a computational artifact, a slideshow presentation, or a website. And we're also going to meet the creating computational artifacts skill and asking students to use the design process to complete those projects is going to hit those skills and procedures in your computer science as well. If we're asking students to use the design process, we're naturally going to also have them covering some of these other skills and procedures out of the computer science that are involved in the design process and, making multiple iterations of something. So we can have opportunities in our projects for other topics where we have students create something and they get some feedback either from the teacher or maybe from some classmates, because that's another piece is providing feedback during the design process. So we give them these opportunities when they're creating projects for us, and they're going to be working that design process, which really develops good critical thinking and problem solving skills as well as meeting this computer science content. Let's have a look at how energy specifically could be connected into computer science in some ways by having a look at those skills and procedures. So students are going to be learning about living things and objects in flight and learning about the concepts of thrust and drag and explaining lift and weight on the flight of living things. So we've got some really specific energy content there that students are going to demonstrate knowledge for, and this is where we can give them the opportunity to design an artifact, some type of a physical model, or possibly to create a computational artifact. And we give them a planning page that has that design thinking process, and have them work through the pieces of that they can. So leading into, for example, doing a paper airplane STEM challenge, that's going to meet these skills and procedures within your energy unit. Construct a device that can fly. Paper airplane meets that need. Practice safe and appropriate use of tools. Definitely anytime we're doing any kind of project and creating, we can be covering that skill and procedure as well. So in addition to these energy pieces, we can draw in from computer sciences. We're designing an artifact. In this case, it's going to be a paper airplane. We can use the design process to move through the challenge to design a paper airplane. What are the conditions? Are we looking for the one that flies the farthest? Well, then, what is your plan to make sure that your airplane is going to fly the furthest? Work through this design process. After we do the tests, see who flies the farthest, why did that one work? Work through going back to the drawing board and replanning based on, seeing all of the airplanes fly. And again, just really working through that design process and teaching students how to do it. Probably a lot of it in the beginning we're going to be doing as a whole class, as we understand each of those steps and work through. And then we have these other computer science skills that we're practicing through doing this challenge for an energy assignment. Describe traditional and modern technologies developed by diverse cultures. So there you have a computer science skill that is specifically about discussing examples of designs that have been enhanced or refined. So as we're talking about technologies, specifically as they relate to forces that affect flight in this topic, this connects directly into this computer science skill as well. And again, we could have students design some type of artifact that could be, a report on paper. It could be a computational artifact, again, slides presentation or a video presentation. Those are going to meet these computer science skills. Asking students to do some research into, the history of flight, having conversations around how things have changed and what do we think they learned from this that made things evolve. And that's going to also bring that computational thinking piece in as we sort of decompose the different aspects of flight and look at the parts that are important and make generalizations about what determines if something can fly. And all of these things can be connected into learning about flight technologies. And again, if you were to have students create something in Scratch that was a game based on these principles that they know about energy, they would be showing you that they understand the energy principles, as well as showing you that they have a bunch of those computer science skills down as well. Let's have a look at now the buoyancy skills and procedures and how we might connect those into some computational thinking. First stage piece of computational thinking is decomposition. If we are talking about buoyancy, we will be looking at particular properties of objects that determine whether or not it will float. So breaking it down, looking at all of the properties of an object first, then into that pattern recognition. Well, what do the ones that float have in common and what is different? And we may lead into conversations about, does it matter if the water gets deeper, in those other pieces of buoyancy that are definitely important as well. Looking at some pattern abstraction, this is where we're going to, remove everything that doesn't matter. Does it matter what color it is? Is that going to determine if it can float? Well, no. all colors of objects can float or sink. So that is an attribute that we're pushing off to the side. We're looking for what is the simplest way we can explain whether or not something will float. That's going to be our abstraction. And then we could push it a step further by going into algorithm design and asking the students to actually write an algorithm for how to determine if an object will float or sink. Could you write a set of instructions that a computer or machine could follow that would make it so that it always categorized something that would float or sink, or something is buoyant or not buoyant, in the appropriate category? What would those instructions in that machine have to be? So we are, learning about energy. We're also drawing in computational thinking, which is a key piece of the computer sciences as well. And then just as in with the other concepts, you have, the opportunity to pull this into some further activities. If we were sorting things out, here's an example of those algorithms. If it is light, then it will float. If it was heavy, then it will sink. Some sort of generalizations. And then we can move further into doing, like a design challenge where, again, we're going to meet this objective of constructing a device that can float. We've got our safe equipment and use again, and we know we're going to meet that as well. Speaking to that one, there's a place where you could ask students to write those instructions, write a set of instructions for being safe during a science experiment, and you're having them practice their computer science algorithm writing skills. With the boat design challenge, again, design thinking. We're going to use the design thinking process to come up with our boats. We're going to be designing an artifact. We will be evaluating that artifact based on whether it floats or not. We may see it sink and then, come up with a plan for how to make it better and make sure it's going to float. And then we're working through these computer science skills while we're also working through these energy skills. The last piece in energy, you also see this in the Earth systems curriculum, talking about renewable and non-renewable energy. So when we have things we're categorizing again, this is that opportunity that we're learning a little bit about computational thinking. We're breaking things down, looking at specific attributes, trying to find those patterns, looking for the simplest way to define a certain category, and then moving possibly into those algorithm designs. What are some rules or instructions that we can write around these topics? And also, just as in with all the other things, because we have this artifact creation and computational artifact creation and that block-based coding, if you have students creating those digital presentations or videos, or building a project in Scratch, an interactive story or a game or anything else that they're doing in Scratch or another block-based coding program, they're going to be showing you that they understand these concepts using their computer science skills, which is going to be transfer of those computer science skills and also help them get to a deeper level of understanding with these energy skills and concepts, because they're moving into the showing someone else into a sort of a teaching place with it. So that is some ways you can connect computer sciences into your energy unit. I hope you enjoyed.